Okay. And then just a reminder, when we interpret the quintile or the decile variable, let's say quintile. So quintile 1 actually stands for the poorest 20% earning the smallest or the lowest per capita income amount. And then quintile 5 stands for the richest 20%. And then similarly for decile. Decile 1 represents the poorest 10% of the households in terms of earnings per capita income. And then similarly, decile 10 stands for the richest 10% of the households in the country. Okay. Next question. Before I do 11.4, I want to first do 11.5. Find out the sum of each consumption category by quintile. Okay. Okay, statistics. Okay. First option, third option, and then first option. Okay. CPI1A. By the way, you don't need to click all the variables if they are really located next to each other. Just put a dash there. So it actually means from CPI1A all the way to the last one, CPI1M. Okay. By quintile, I want the sum. Remember, not the mean anymore. Sum. Total spending on each category in each quintile. And weight, this is the first time we type the weight here. Frequency weight, because we have to round off to integer. Okay, integer household weight, and then close round bracket. I leave it for another 10 seconds. Okay. Then you're going to see some scary results. Okay, I think the amounts are too huge. So for instance, this actually means total consumption on 1A, which is food and non-alcoholic beverages in the poorest quintile amounts to 2.55 times, I think 10 to the power of 10. And now the problem is then how can we interpret these answers if the values are too huge? So I think what we need to do is we have to convert these CPI 1A, 1B, and so forth into million terms, okay? So this is why we have to go back to 11.4, okay? I want to replace CPI 1A as the original CPI 1A divided by 1 million. Then the value will be expressed in million terms. Okay, let's do 1 or 2, then I think we can have valid reasons to be lazy and then just execute the commands, okay? So replace the first one is equal to its existing value divided by 1 million. I just need to make sure there are 6 zeros. Okay. And then replace the next one, CPI1B equals CPI1B divided by 1 million. Again, make sure there are 6 zeros. Okay. Then I think we can run these commands from 471 to 482. We have valid reasons to be lazy, okay? Okay, select these commands from 471, to 482, execute. And then you can see Stata is very friendly running the commands on your behalf. Now we can redo that statistical table. Just exactly the same commands, except these values have now been converted to million terms. Okay, so I think it is now much easier to interpret the answers. Then you can copy and paste. Actually, by the way, how can we copy and paste actually? So copy, right click as table. Okay, then you can paste onto Excel. And I already did that. Remember the Excel file called Stata. Okay, so that is the results. Okay. And then using mathematical calculation, you can open your Excel file and then you can see the equation. So I derived the consumption on each category as percentage of total. So for this one, 33 point something, it actually means this divided by the total consumption. So this is actually the food spending and then housing, transport. So you can see the changes in this proportion as we move across to the richer quintile. So for the poorest quintile, the household spend 1/3 of their consumption on food, which is an essential item for survival, and they only spend 11% of their consumption on transport. But when it comes to the richest quintile, they only spend 6.5% on food, but they spend much higher proportion on housing. I think it makes sense because the households from the richer quintiles, they most likely have purchased properties. They're going to pay the bonds, maintenance, and so forth, and expect them to be able to afford purchasing a car, motor vehicle, so they would spend more on transport, maybe petrol, again, the services on the cars, and so forth. Okay. So this is how we as economists interpret the data. Okay, we do some analysis on Stata, then we probably have to do some copy and paste onto Excel, then we derive these percentage shares, and then we interpret the answers and present to the audience. This is how we conduct research as an economist. And in the country, we lack economists who can analyze data thoroughly in detail and then present the results in terms of tables and graphs, and then write up a good report. And when you work as an economist, one day you have to do a lot of oral presentation. You need some good communication skills, and this is why I asked you to do 3 oral presentations for your honors research project. I want to subtly help you to develop your graduate attributes. It's not just academic knowledge, but communication is very important. Okay. So we finished 11.4 and 11.5, and then 11.6, I want to look at the relationship between race and quintile. And then again, I want to refer back to the commands we learned earlier, no frequency and so forth. So let's do the easiest crosstab. Household race and quintile. Always remember from now on, we would use the weight variable. Okay. It's hard to interpret the results, so let's redo this command, but comma, no frequency, but show the percentage share along each row. Okay, so how can we interpret the answers? Maybe let's look at this one, just randomly look at the white-headed household. Then it actually means for the white-headed households, 76% of them fall under the richest quintile, and only about 2% fall under the poorest quintile. Okay, and then I do the same command, but this time rather show the percentage share for each column. Okay, so how can we interpret the answer? So let's look at this column. It actually means for the poorest quintile, quintile 1, 95% of the households in the poorest quintile, they come from the African population. And then when we look at the richest quintile, quintile 5, it's quite encouraging, the results. The African share is close to 40%, okay? And then the color share, 9%, and so forth. And then the last one, we never learned yet, okay? Rather no frequency, but cell. So it actually means this would be your total 100%, okay? All these cells add up to 100%. So what does this mean? 18.91, then it actually means out of all the households, obviously weighted households, 19% of the households are headed by Africans, and they fall under the poorest quintile. And then maybe this one, it means out of all the households in the country, 9% of the households are headed by white and falling under the richest quintile. Okay. So I leave these answers for 30 seconds just to make sure we all on the same page. Okay, then we can move on to the next one. Okay, now we have to merge the 2 household files, household 1 and household 2. This is the first time we are doing the merging, so I'm going to do it a bit slowly. Okay, so the existing file that is already open is household 1. I want to merge it with household 2 file, which includes all the non-income welfare variables, so I will do it slowly. data, combine data sets, then the second option, form all pairwise combination within groups. So I will leave it for 5 seconds. Okay. I need to look for the household 2 file location, which is here. And then I need to type the unique number. Okay, I don't remember how to spell it, UQNR. So this is the key crucial variable that would help merging the 2 files together. And then we have to go to options, click the second option, include from both datasets, just in case we have some unmatched observations. What do we mean by unmatched observations? So it actually means, what if we have a case that, let's say in the first file, there are only 4 households taking part, and then in the second file, there are 5 households. So there will be one unmatched observation. Okay, so by clicking the second option, then I'm telling Stata, although there could be some households that only appear in one file but not in the other file, when I create a merge file, please include all households. Okay, so this is what it means with the second option. So in other words, in the merge file, please don't leave out the 5th household, which did not take part or exist in the first file. Okay, so I think I can click OK. Okay, and then there is a variable added called merge. Actually, we can tap this merge, it will give you the results actually. Perfect matching, it means all the household exist in both files. So perfect matching, 100% perfect matching. You should remember this sample size, 25,000 households taking part. So we can now drop the merge file. Okay, now we combine or merge the 2 household files together. Okay, so let's do some tabulations. Okay, tap on dwelling. Okay, just out of curiosity. Okay, scary, hey? Stats SA created a label and labeled the categories, but using capital letters. Okay, so you can see at the time of IES 2010, 2/3 of the household live in formal dwelling. And then I think I did it before. What if I don't want to see the label? I only want to see the category numbers. So no label. Okay, let's do 2 more. Maybe I want to know the DSTV ownership by quintile. DSTV. Maybe I go straight to the no frequency percentage row results. So you can see for the richest quintile, 60% of them have DSTV membership, but only 4% for the poorest quintile. And nationally, only about 1/4 of the population had DSTV. Okay. And let's do the last one. The percentage of households with pet. Okay, at least one pet. It could be dogs or cats, but by province. And again, I will go straight to the no frequency, ROW option. Okay, so it seems we have lots of pet lovers in Western Cape. Look at this highest proportion, 37% of the Western Cape households own at least one pet. And nationally, this proportion is 16%. Okay, and then we can save this merge file as IES 2010 underscore HHH. Okay, the name is a bit strange actually. HHH. Okay. And then what we are going to do later, we want to merge the household file, this merge household file, let me call it HHH, with the person files. And again, person file, let me first explain the story. Maybe age. I just want to simplify explanation. I assume 2 people in the households, in each household. Then I randomly put some age. Okay. So again, I need to make use of the unique ID, unique household number to merge the household file and the person number together. So that will be my merge file. And then